Service entrance installation. What is an electricity meter? An electricity meter, electric meter, electrical meter, or energy meter is a device that measures the amount of electric energy consumed by residents, a business, or electrically powered devices. It measures electricity consumption in kilowatt-hours kWh. Your billing will be based on the differences between two consecutive readings, by subtracting the most recent with the previous one. Typically, a meter is installed at the point where the power lines enter your building. It consists of prongs plugged into the meter base, a meter number which is registered to a specific consumer, a register which records power consumption, transparent cover that protects mechanism, a seal that serves as authentication to prevent tampering, and a nameplate that bears the manufacturer. Materials and devices used in meter installation. A meter box is a device used to house a building's electrical meter. Adapter, lock nut used to secure rigid and IMC conduit and various threaded fittings to steel outlet boxes and other metal enclosures. Zinc plated for corrosion resistance, these conduit lock nuts can be used for outdoor applications. RSC or EMT pipe 3/4 steel conduit, usually fabricated of steel, which encloses electrical wiring, thereby protecting the wiring from outside damage. Clamps, straps. Conduit clamps or pipe clamps allow the pipes to be safely attached to walls or ceilings, so wiring is kept out of harm's way. Conduit fittings are connectors and fittings used to connect one piece of conduit to another or to connect conduit to an electrical box. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. The electrical box has to be attached outside the home. Regulation was imposed by the fire department, so they can quickly shut off all the electricity to the house in case of fire. Service entrance wire, minimum of 8.00 square millimeters size of copper wire, color coded with a protective ground is green or green with a yellow stripe. The neutral is white, the hot, live or active, single phase wires are black, and red in the case of a second hot wire. Meter offset used to connect between metallic conduit and electric meter. Electric meter box, base installation, pole. Figure 7 shows how a meter box is installed. The metallic box, base has to be weatherproof if installed outdoors on a metallic pole. The meter box can't be less than 4 feet high or not higher than 6 feet high from floor level. A conduit is connected to the 2 meter box using an adapter, lock nut indicated by number 1, service entrance. Insulator of neutral wire with standard color is removed and screwed at the middle of the meter box indicated by number 9, metering ground. Likewise, a 3 breaker box is grounded all the way to 5 ground rod. A 6 circuit breaker is installed with an amperage based on the requirement. Another conduit is connected right after the 4 breaker box as service lateral to the main panel. All metallic meter boxes must be grounded. 7. Energy meter installation is done by service provider field electricians, simply by plugging in the specific 8 prongs to the socket of the meter box. Electrical grounding. Ground, in electricity, a connection in an electrical circuit that leads to the earth, or to a large conducting object that is at zero potential concerning the rest of the circuit. Importance of electrical grounding. In an electrical circuit, there is what's known as an active wire, which supplies the power, and a neutral wire, which carries that current back. An additional grounding wire can be attached to outlets and other electrical devices and also securely connected to the ground at the breaker box. This ground wire is an additional path for electrical current to return safely to the ground without danger to anyone in the event of a short circuit. If a short circuit did occur, the current would flow through the ground wire, causing a blown fuse or tripped circuit breaker, an outcome much preferable than the fatal shock that could result if the current were not grounded. 1. Protection against electrical overload. One of the most important reasons for grounding electrical currents is that it protects your appliances, your home and everyone in it from surges in electricity. If lightning was to strike or the power was to surge at your place for whatever reason, this produces dangerously high voltages of electricity in your system. If your electrical system is grounded, all that excess electricity will go into the earth rather than frying everything connected to your system. 2. Helps direct electricity. Having your electrical system grounded means you will be making it easy for power to be directed straight to wherever you need it, allowing electrical currents to travel throughout your electrical system safely and efficiently. 3. Stabilizes voltage levels. A grounded electrical system also makes it easier for the right amount of power to be distributed to all the right places, which can play a huge role in helping to ensure circuits aren't overloaded and blown. The earth provides a common reference point for the many voltage sources in an electrical system. 4. Earth is the best conductor. One of the reasons why grounding helps to keep you safe is because the earth is such a great conductor, and because excess electricity will always take the path of least resistance. By grounding your electrical system, you are giving it somewhere to go other than into you, possibly saving your life. Earth resistance is greatly affected by soil moisture content as it gets lower as displayed in an instrument. The real Earth, the planet you are probably standing on, is electrically neutral. This means that it has the same number of electrons and protons, so their charges cancel out overall. Scientifically, we describe this by saying that the Earth has an electric potential of 0. 5. Prevents damage, injury, and death. Without a properly grounded electrical system, you are risking any appliances you have connected to your system being fried beyond repair. In the worst case scenario, an overload of power can even cause a fire to start, risking not just extensive property and data loss but physical injury as well. Types of grounding. Grounding in the household electrical system is the same with transmission and distribution lines, thus understanding its type is a must. 1. Ungrounded. Electrical power systems that are operated with no intentional connection to an earth ground are described as ungrounded. Although these systems were standard in the 40s and 50s, they're still in use today. The main advantage of this type of grounding system is that it offers a low value of current flow and reliability during a fault. The occurrence of a second fault will more likely be decreased than the grounded system fault. 2. Solidly grounded. This type of grounding system is most commonly used in industrial and commercial power systems, where grounding conductors are connected to earth ground with no intentional added impedance in the circuit. A main secondary circuit breaker is a vital component required in this system, although it has no bearing in other grounding systems. The neutral of any grounded system will permit the flow of current through the conductor when the unbalanced load is connected. 3. High resistance grounding. High resistance grounding, HRG, systems are commonly used in plants and mills where continued operation of processes is paramount in the event of a fault. High resistance grounding is normally accomplished by connecting the high side of a single-phase distribution transformer between the system neutral and ground. How does grounding work? In most homes, the wiring system is permanently grounded to a metal rod driven into the ground or a metal pipe extending into the house from an underground water supply system. A copper conductor connects the pipe or rod to a set of terminals for ground connections in the service panel. For wiring systems that use electrical cable covered in metal, the metal usually serves as the ground conductor between wall outlets and the service panel. In wiring systems that use plastic sheathed cable, an extra wire is used for grounding. Since electricity is always looking for the shortest path back to the earth, If there is a problem where the neutral wire is broken or interrupted, the grounding wire provides a direct path to the ground. Through this direct physical connection, the earth acts as a path of least resistance, preventing a person from becoming the shortest path, and suffering a serious electric shock. Electrical grounding materials. Ground rods. Ground rods can be made with many different materials, but the most common is galvanized. Grounding terminal. Grounding terminal accepts wire with a range of sizes. Grounding installation procedure. 1. Picking the location. Install the rod in a location near the electrical panel where they can be hammered into the ground around 2 meters deep. No requirement for how close or how far from the building as long as it is convenient to use tools and driving bolt. If a grounding rod is too close to a building foundation, it could interfere with it. Because of this, it's best to keep it at least 2 feet, 0.61 meters, from the side of the building. 2. Putting the rod in the ground. Grounding rods need to be made of specific conductive metals and they need to make to a specific length and fault width. Because of this, it's best to buy a rod that is specifically made for this use. Buying a listed rod, meaning it has been verified by a certification group, will ensure that your grounding rod is the correct size and material. Most home improvement and hardware stores stock approved grounding rods. A. Start digging a hole with a shovel or post hole digger. B. Drive the rod into the ground. 3. Connecting the rod. A. Pull the grounding electrode conductor to the grounding rod. B. Clamp the grounding electrode conductor to the grounding rod. C. Connect the grounding electrode conductor to the ground bus. Is your electrical system grounded? You can usually tell whether your electrical system is grounded by checking your power outlets. If they accept plugs with 3 prongs, your system should have 3 wires, one of which is a grounding wire. Similarly, an appliance designed to be grounded is equipped with a 3-wire cord and a 3-pronged plug. The 3rd wire and prong provide the ground link between the metal frame of the appliance and the grounding of the wiring system. When dealing with appliances, make sure you A. Do not touch an appliance if its cord's insulation has begun to wear away where it enters the metal frame. In this situation, contact between the metal current conductor and the metal frame could make the whole appliance live with electricity, and touching the appliance could cause the current to surge through you. B. Inspect, maintain, and organize repairs of wires where they enter a metal pipe, an appliance, or wherein wall cables enter an electrical box. The best thing you can do to create a safe electrical system is to ensure the whole system is grounded and the ground circuit is electrically continuous. C. Grounding your electrical system is a smart and easy way to make it a whole lot safer, as well as to protect against the very real possibility of having to deal with fluctuations in power supply. If you want to safeguard all your important assets, whether at home or at the office, as well as look out for the health and safety of everyone around you, find out if your electrical system is not grounded. The end.